Hey guys, welcome to Final Exam Guy. It's going to be my first video in physics mechanics. We're going to be doing solved problems in all the topics of mechanics. So before we start, smash that subscribe button so that you never miss out on any of my videos and you're able to follow this whole course with me. Also, like this video and share it with your friends so they learn about mechanics as well. Let's get started here. So our first problem says a person walks at a constant speed of 5 meters a second along a straight line from point A to B, and then back along the line from B to A at a constant speed of 3 meters a second. What is her average speed over the entire trip, and what is her average velocity over the entire trip? Alright, so let's try this out before anything. So we got point A and point B. So it says that she travels here at a constant speed, v, so 5 meters a second, and then she travels back at a constant speed of 3 meters a second. So what is her average speed over the entire trip? So it's important to distinguish between average speed and average velocity. Let's work on the average of velocity first. Velocity average is the total distance traveled over total time it took. So we got to find the total distance and the total time to solve this problem. So for the first trip, we'll call the first trip time 1. And we know that time 1, velocity is distance over time, so time is distance over velocity. We'll call that first velocity v1. So this is v1, this is v2. And the same way we can find t2 as well. T2 would be the distance. It's the same distance back and forth, so x is the same, and over v2. So the total time, we'll call time t, would be x over v1 plus x over v2. Correct? So if we can factor out, we can actually factor out an x here. X, v1 plus v2, common denominator, v1, v2. Right? Good so far? So what is the total distance for this top part of the equation? Total distance is how much she went forward, how much she went back. So we'll call the distance x, so the total distance one way was x, total distance back was x, so 2x would be the distance, right? So the velocity average, and we'll call d equals 2x, is the total distance 2x over x v1 plus v2 over v1 v2. Great. So now the x's will cancel out, so we'll just have 2 v1 v2 over v1 plus v2. If we plug in our knowns, so 2 times v1 is 5 meters a second times 3 meters a second over 5 plus 3, so 8 meters a second. And so solving this, we get 3.75 meters per second is the average speed. Alright, here's where we distinguish between average and speed and then velocity. So average velocity not to be confused, I should have wrote average speed here. Average velocity is the total displacement. So total displacement is how much was actually traveled. Like where she started at some point, she ended at another point, and then she went back to the beginning. So her total displacement and the end was just 0. She ended up back in the same spot. So that's the difference between total displacement and total distance. So her total displacement, and this is over total time, she ended up back to square 1. So her total displacement was 0, and it doesn't matter what her time is. The answer is just 0. That's our average velocity. Alright, move on to the next question. Alright, question 2. A 50-gram super ball traveling at 25 meters a second bounces off a brick wall and rebounds at 22 meters a second. A high-speed camera records this event if the wall is in contact with the wall for 3.5 milliseconds. What is the magnitude of the average acceleration of the ball during this time interval? Alright, so they're asking for the magnitude of the acceleration average. And we know that acceleration average is just the change in velocity over the change in time. So in other words, velocity final minus velocity initial over time final minus time initial. So we got the ball traveling this way and bouncing back that way. So our positive direction will be to the right and our negative will be to the left, so that we know that velocity initial is 25 meters a second and velocity final has to be negative 22 meters a second. And the time it's in contact, they're asking for the time in this time frame here, so this essentially is the change in time. So if we plug in our values here, we get negative 22 meters a second minus 25 meters a second, and we're in milliseconds. We have to convert to the appropriate units. So we have to get it in seconds. So the dimension would be this, negative 3 seconds and over 1 millisecond. And our answer would be 1.34 times 10 to the 4 meters a second squared. That's the average acceleration. Alright guys, question 3 says an object moves along the x-axis according to the equation x of t is equal to 3t squared minus 2t plus 3 meters, where t is in seconds. Determine A, the average speed between t equals 2 seconds and 3 seconds. So let's do part A first. Okay, we got the equation of our displacement. Let's go to, I'll shorten it a bit, 3t squared minus 2t plus 3 and meters. So they want the average speed between time, so t1 is equal to 2 seconds, t2 is equal to 3 seconds. So we gotta find out how much was traveled for each time. So we gotta plug in 2 seconds into our equation, 3 seconds into our equation, see what happens. So x of 2 would give you 11 meters. X of 3, if you plug that into there, you'll get 24 meters. So that is your distances, and the average is your final distance minus your initial distance. So 24 minus 11 over your time frame, so 3 minus 2. And appropriate units, we get 13 meters per second. Now we go on to part B. So part B says to instantaneous speed at t equals seconds and 3 seconds. Alright. So with what we currently have, there's no way we can calculate instantaneous speed. We actually need to derive this equation to get the velocity function. So we know that the velocity is dx by dt, which is equal to d by t dt of our function 3t squared minus 2t plus 3. So if I go ahead, and then we get our velocity function, a is equal to 6t minus 2, and the constant goes to 0. And now we can just plug in our instantaneous moment of time and get our instantaneous speeds. So v of 2 So that would give us 6 times 2 minus 10, which is 10 meters a second at that moment in time. And v of 3 is equal to 6 times 3 minus 2, 16 meters a second. Now let's move on to part C. Average acceleration between t and t3. So average acceleration, we did it in the last problem, is just the change in velocity over the change in time. v2 minus v1 over t2 minus t1. So we use this information here because we know the velocities at these moments of time. So we'll get 16 minus 10, and our change in time 3 minus 2. So we get, solving this, we get 6 meters per second squared. And part D asks us to find the instantaneous acceleration at times t and 3. So you guessed it, we have to derive for our acceleration equation. So a of t, we know, is equal to dv of t by dt. So goes to d by dt of 6t minus 2. So it just gives us 6. That's our acceleration formula. So now we obtain a constant. So this means that this is our acceleration no matter what at these times, time frame 2 and 3. So it's going to have a constant acceleration at this point. Alright, let's move on to the next problem. Alright guys, question 3 says that t equals 0 times 0, one toy car is set rolling on a straight track with an initial position of 15 centimeters and an initial velocity of negative 3.5 centimeters second and constant acceleration 2.4 centimeters squared, second squared. At the same moment, another toy car is set rolling on an adjacent track with initial position of 10 centimeters and an initial velocity of 5.5 centimeters a second and constant acceleration 0. Part A says, at what time, if any, do the two cars have equal speeds? Alright, so what we're going to have to do is find the final velocities of each car, and if we set them equal to each other, that means they have to be the same, so we can solve for the time that happens, right? Makes sense. So we know from mechanics equations of motion that v final and with constant acceleration equals v initial plus a times time. Constant acceleration always. So for the first car, our velocity final is equal to, so we're given our initial velocity 3.5 plus our acceleration we're given is 2.4 t. Alright, and for the second car, v final is equal to, so we're given our initial velocity 5.5 and plus acceleration, there's no acceleration, so the velocity is the same as vf is equal to v initial. So all we got to do now is set, so we'll call this vf2, vf1, vf1 equals vf2, and we'll get the time that they have the same velocity. So I'll set negative 3.5 plus 2.4 t equals to 5.5, and if we solve this we get 3.75 seconds. So the cars will have equal speeds at 3.57 seconds. Alright, let's move on to part B. So part B says, let's move over. Part B says, what are their speeds at that time? Well, it's obvious that their speeds are both still 5.5 centimeters per second at that time, both of them. That was simple, oddly. So part C, at what time, if any, do the cars pass each other? Alright, so we need to find their the distance traveled for each car, and we have to note here that car 1 is ahead of car 2 by 5 centimeters, right? So that's going to play a role in our answer here. So we know that the equation of motion to determine distance is v1, v initial, time plus 1/2 at squared, right? So for car 1, we get that x is equal to negative 3.5 t plus 1/2 2.4 t squared. And for car 2, so this toy car has to travel an extra 5 centimeters in the same time for them to pass each other, right? So we have to put x plus 5 here in the distance to account for that. So v initial for the time for the car 2 is 5.5 centimeters, and the whole second term is 0 because acceleration is 0. So all we have to do now is set these two equal to each other, and we get negative 3.5. Well, what we would do is we would solve for x here, so we get x is equal to 0.5. If we plug it into that equation, now we get 0.5 is equal to negative 3.5 t plus 1.2 t squared. So I bring over everything to one side. We get 1.2 t squared minus 3.5 t minus 0.5. And this is a quadratic equation. If you solve it using the quadratic equation or some calculator that you have, you get two positive times, 0.604 seconds and 6.8 seconds. So because they're both positive, they're both valid, so the cars pass each other twice at these 2 seconds here. Alright guys, question 4. A student throws a set of keys vertically upward to her sorority sister who is in a window 4 meters above. The keys are caught 1.5 seconds later by the sister's outstretched hand. With what initial velocity were the keys thrown? So this is a free-falling object problem. I drew a little diagram for you guys. I know you love it. So I drew the diagram here, and they give us some knowns such as the height from this point to this point. This height here is 4 meters. And the total time that this process happens in is 1.5 seconds. So we're going to have to use our free fall equations that are given in your textbook. H, height, is equal to initial velocity times time minus 1/2 at squared. So we know that h is 4. T is equal to 1.50, sorry. And that gravitational acceleration for free falling is 9.8 meters per second squared. So if we plug all this in, we get 4 is equal to v1, 1.5 minus 1/2 9.8 times 1.50 squared. So if we isolate for v1, we get 10.01 meters a second. So part B says, what was the velocity of the keys just before they were caught? So it's asking for a velocity final, basically. So we know that the equation from your textbook with free falling, it's going to be velocity final, it's v initial minus gravitational acceleration time. So is equal to, we have the initial velocity now, so 10.01 minus 9.8 times our time is 1.5. So the answer to this question here is that the velocity final is negative 4.7 meters a second. And what does this mean? This means that the velocity, this indicates the downward direction. So they're giving us we solve for the velocity in the downward direction. So if you want, you can just put 4.7 meters a second downwards as your answer. Alright, let's move on to the final.
Alright, so question 5 says the speed of a bullet as it travels down the barrel of a rifle towards the opening is given by negative 5 times 10 to the power 7 t squared plus 3 times 10 to the power 5 t, where v is in meters per second and t is in seconds. The acceleration of the bullet just as it leaves the barrel is 0. Determine the acceleration and the position of the bullet as a function of time when the bullet's in the barrel. So when it's in the barrel, it has an acceleration. Determine the time interval over which the bullet is accelerated. Okay, let's first ahead go and do A. So determine the acceleration and the position of the bullet as a function of time. So we got the equation. We're given the velocity function as a function of time. So it's negative 5 times 7 t squared plus 3 times 10 to the 5 t. So we know that to get the acceleration, we have to take the derivative of a velocity function. So if we take our derivative, we derive this first term, bring the 2 to the front, multiply by negative 5, we get negative 10 times 10 to the 7 t. And this, we just take the constant here, so plus 3 times 10 to the 5. So that's our acceleration function. And now it wants the position as well, and we know that to get the position, we know that dx dt is equal to v, right? So if I take the integral here, we get x is equal to the integral of our velocity function dt. So our velocity function integrated is equal to the integral of negative 5 times 10 to the 7 t squared plus 3 times 10 to the 5 t. All of that is dt. So we know how to do this. We end up getting negative 5 times 10 to the 7 over 3 t cubed plus 3 by 2 10 to the 5 t squared. But we have a constant as well, don't forget that, because it's indefinite integral. So we know some initial conditions here. We know that at time 0 the position is obviously 0, so if we can plug t equals 0, x equals 0 into our equation and solve for the constant, we know that we will get, the constant will be equal to 0. So this is our actual function of velocity. And if I go ahead and divide and multiply that out, we get negative 1.67 times 10 to the 7 t3 plus 1.5 times 10 to the 5 t squared. So that's our final velocity position equation. And let's go to part B. So the particle, it's asking part B, determine the time interval at which the bullet is accelerated. So the bullet accelerates from when it first is at the beginning of the barrel, and at the end of the barrel the acceleration is 0. So that's the time interval where it's accelerated. So all we have to do here is plug in 0 for our acceleration into our acceleration equation. If we do that, we'll get the time at where the acceleration becomes 0, which is the time interval over which the bullet is accelerated. So negative 10 times 10 to the 7 is our acceleration equation, and we set this equal to 0, t plus 3 times 10 to the 5. We set it all equal to 0, and if we do that, we end up getting t is equal to 3 times 10 to the negative 3 seconds. Part C, find the speed at which the bullet leaves the barrel. Alright, so this is the time at where the acceleration is 0, which is a time where the bullet is at the end of the barrel. So we can plug this time into our velocity function. If we do that, we actually get our answer to our question, speed at which it leaves the barrel. So we know that our function at velocity is negative 5.6 times 10 to the 7 t squared plus 3 times 10 to the 5 t. And if I go ahead and I plug in our time that we just solved, you should calculate this out, plug in 3 times 10 to the negative 3 for our time, you get 450 meters a second. So question D, what is the length of the barrel? This basically asks us what is the distance of the bullet. The bullet has traveled from the beginning to the end, All we got to do here is plug the time interval that we solved for, this one here, into our position equation. And we had said that our position equation was negative 1.67 times 10 to the 7 t cubed plus 1.5 times 10 to the 5 t squared. So x of 3 times 10 to the negative 3, if we solve that, we get 0.9 meters. Alright guys, that's the end of our 1D motion solve problems video. If you learned something here today, support me by subscribing to my channel and share this video so everyone can learn about the one-directional motion. I'll see you guys in the next video. Take care.